Hello, my name is Neda Mukhtari, and today is July 1st, 2023. I will be presenting a data set calculation for gene mapping today. I apologize ahead of time. I have laryngitis, I've lost my voice, coming out of a very bad virus, but I'm going to do my best. Alrighty, so this is the data set that we will be evaluating today. As you can see, there's varying values for each of the genes. The highest number of offspring will be considered no crossover, and the two with the lowest offspring are going to be denoted as double crossover. As you can see, there's varying values in between all that, so I will take a moment to label each one for you, and we'll go over them one by one. Each value set is going to be denoted as either no crossover, single crossover, or double crossover in each of these recombinant classes. As you can see, the first value is one of the highest values, so it'll be considered no crossover. The second is also one of the highest values in this data set, and it's also considered no crossover. This third one is going to be one of the middle values, so we'll denote it as a single crossover. There will be two groups of single crossovers as there's a big gap between the values, as denoted by this number 1 in the first group. Then we have a double crossover, as this is one of the lowest values. And then we have a single crossover, which will be in the first data set due to the value being close to this one. And then we have another single crossover, but this time it'll be group number 2, as it's much higher than the first two numbers in the single group crossover groups. And then I have a double crossover and a single crossover, as this is one of the higher ones, and I'll be in a group number 2. Since the no crossover group is denoted by a plus and an ABC, and the double crossover group is denoted by an A++ and plus BC, to have it be a correct gene order, it would be BAC, as we can see from these two values. Remember, the gene order is BAC. So that's how we will be calculating the distances. So first off, we're going to look at the distance between B and A. The distance between B and A is calculated by doing the double crossover plus the single crossover all over the total offspring times 100, which will be equal to 100 plus 140 plus the value of 420 plus 400 all over the value of 5742 times 100, which will be 18.46 map units. The distance between A to C will be, again, calculated by double crossover plus single crossover over the total offspring times 100, which equals 100 plus 140 plus the value of 970 plus 1,010 all over 5,742 offspring times 100, which equals 38.66 map units. And then we have the proper outline here for you. BAC, the distance between B and A is 18.46 map units as calculated above. The distance between A and C is 38.66 map units as calculated above. To evaluate for the coefficient of coincidence, we have to calculate all DCOs, the double crossovers, over the distance 1 that we calculated above times the distance 2 calculated above times the total offspring, which will equal 240 for all the double crossovers over, remember that when we're doing this, the denominator, I know that we applied times 100 above, here to get the percentage of down here, it has to go back in decimal value. So divide by 100. So it'll be 0.846, which is here, times 0.3866, as we found here, and the total number of offspring, which is 5742, which will equal 0.58. The coefficient of coincidence will be 0.58. Interference is calculated by 1 minus the coefficient of coincidence, which is 1 minus 0.58, which will equal 0.42. The interference will be 0.42. Thank you so much for listening to this calculation. I apologize again for my voice. Have a wonderful day.